Welcome back. In this video, we're going to be looking at an integral test problem for the series of this 1 over 2n plus 7 quantity to the third. What the hell? We can't find the sum of that by any means that we've seen. We probably could find the sum if we thought about it hard enough and we went to grad school for 3 years. We could do that, but not now. Sorry. That sucks. But anyways, what we're going to do in this video is we're going to see, is this series convergent or divergent? And to do this, we use the integral test. Do the divergence test on this. What that says is take the limit of our sequence. If the limit is 0, it is indeterminate of whether we're divergent or not. And we have to do another test. If it turns out that we get a value other than 0, that series is divergent. Well, what you'll notice is when you take the limit as n approaches infinity, 2 times infinity is infinity, you're going to get 1 over infinity for that value. That's going to be 0. So this is indeterminate by the divergence test. So we have to do what's called the integral test. Remember that there are 3 conditions for the integral test. You always have to be positive. 1, from the interval of which your series starts and ends. I dropped my marker. Are we always positive from 1 over 2n plus 7 to the third? You'd say yes. No matter what value you plug in to this, it will always be positive. Is it always decreasing? Well, you'd say yes, right? Because if we plug in a value here, plus 7 to the third, it's always going to be decreasing for every part of the sequence that we have, right? So you can prove this. I won't prove it in this video. You know, on a test you probably would. You'd make a comparison, right? But we're just doing the integral test in this video to see if it's convergent or divergent. Now, we're always positive, right? Because all values are positive, and it's impossible for us to get a negative value from this term here. Always positive. That's pretty obvious. Always decreasing, 1 to infinity. Yes, we're always decreasing. Because we're growing that value in the denominator. We know that that's going to decrease our value as we input higher values. So yeah, we're always decreasing. Is it always continuous? This one might be a little difficult. Just look for holes. Look for any asymptotes. We're always continuous here. This function is just going to kind of go like this, right? It's going to be like, right? So yes, it's always continuous. There's no holes. So we passed the 3 criteria that we need for our series to do the integral test. So let's do the integral test. How exactly do we do that? Well, we are going to rewrite our series as if it were a function. Okay, so we're going to put this in terms of x, 1 over 2x plus 7 to the third. Okay, so we have that written out now. We're going to take the integral of 1 to infinity of 1 over 2x plus 7. Now, there's an important thing here to notice. If our integral turns out to be convergent, what it tells us about our series is that it's also convergent. That's why we do this, okay? It's going to tell us, well, should I even waste my time trying to find a sum if it goes to infinity? Well, if it's convergent, you know that, okay, yeah, I'm losing my train of thought here. But you kind of get the point, right? Sorry, someone has a glistening bag outside. It caught my eye and completely made lose my train of thought. But if the integral is convergent, then our series is convergent. But if our if the integral is divergent, our series is divergent. So this is just an improper integral problem, so let's rewrite it as the limit as b approaches infinity. For the integral of 1 to b, 1 over 2x plus 7 to the third. Alrighty? Let's rewrite this, and this should be dx. Oops, I forgot. Let's rewrite this by saying this is actually 2x plus 7 to the negative third. And we're just going to do a simple u sub for this. So u is equal to 2x plus 7, where du is equal to 2. Notice here we have a coefficient of 1, so we need to make du equal to 1. So this is 1/2 du, or du over 2 is equal to 1. Alrighty, now let's just plug everything back in. The limit as b approaches infinity, 1/2 integral b to 1 for u to the negative third. Now let's do inverse power rule. The limit as b approaches infinity for 1/2. Now this is going to be 1 over negative 1/2 u to the negative second. And we're evaluating this from b to 1. Okay, we're going to combine our constants here and plug u back in. So let's do that. 1/2 times negative 1/2 is 1/4, negative 1/4. And our u, that's 2x plus 7. So 2x plus 7. Now, we're going to write this in the denominator now to make things a little simple. A little simpler, I should say. Okay, hopefully this wasn't too hard to find. But what you want to do next is plug in 1, then plug in b, and evaluate your integral. So this is going to be negative 1 over 4, 2 to the infinity plus 7, minus, I'm just going to evaluate what this is equal to in my head because I'm actually quite lazy. 4, 2, 1, plus 7 squared. Plus 1 over 3, 2, 4. Okay, so I'm not going to really care what this is here, but I'm going to look at this and I'm going to say, dear Lord, 2 times infinity is infinity, plus 7 is infinity, times 4, that's infinity. So this is negative 1 over infinity. That's just going to simplify to 0. And we're going to notice that we're converging to this value. It's not infinity, it's not diverging into infinity. We're converging to a singular value. This is not equal to the sum, but it tells us that because our integral is convergent, our series is convergent based off of the integral test that we're allowed to do. We're always positive, we're always continuous, we're always decreasing. So we're allowed to do the integral test. So you're going to notice that this is a convergent series. Okay, we did not determine in this video what the sum is. This is not the sum, but we know it's convergent, and we could find the sum if we really tried hard enough. Hope you guys enjoyed this video. If you did, please drop a like, comment, and subscribe, and I hope that you have a wonderful day.